মাহবুবুর রহমান। Mahabubur Rahman. I am calling you. Give me response me. Mahabubur Rahman. If you don't respond me, I will disconnect you from my class. Guys, can you hear me? All of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Mahabubur Rahman. This is for the last time. Why don't you give me answer? Okay, I won't accept you in my class. Leave.
Maybe net problem.
No, that's not the net problem. He does not give his midterm exam. So why he come and travel in my class? So, guys, listen this algorithm very carefully. Whatever I am writing in the Microsoft Word, all of you should write it down in your copy. Otherwise, you will forget the algorithm and then you will get 0 in your exam. Because in the exam, at your final, I will give all types of algorithm with mathematical formula. So this algorithm is first come first serve and it is non-primitive algorithm. Non-primitive algorithm means already I have told you what is actually non-primitive, that does not allow any interrupt. It only focus on its execution work. So it actually follow the rules of first in first out queue. This type of work and the poor in performance as average wait time is very high. Because whenever the algorithm is for first come first serve, at that point of time it does not think about the time. It only focus on the execution work. So at that point of time, if a process that needs too much time, it actually takes a lot of time for that process. So you see, this is the process. There are several types of process. So this process is come first, P1 and P6 process come last. So P1 will be give the output the first and P6 will give the output at the last. So that is actually first come first out serve job. So if P1 process need total 25 minutes for complete its whole task, at that point of time, it only execute within 25 minutes to complete the first task. It does not go for the second, third, or the other task. That is the problem that average waiting time is very high. Now, first of all, this is the mathematical formula for first come, first serve scheduling. So in the exam, I will only give you the PNO. PNO means the process number, waiting time, and the burst time. You have to calculate and find out the completion times, turnaround time, and the waiting time. These three things. So first of all, you see I give total 5 process and I also give the arrive time and the burst time. Now first thing we need to calculate the completing time. So first of all, to find out the completing time, you need to create this type of column. This is actually called the Gantt chart. So this is my Gantt chart. In the Gantt chart, I put all of my process 1, 2, 3, 4, 5. So my first process arrived at 0 and burst time means total time that need to be executed, which is 4. So up to 4, the process 1 completely done, and at that pointing line, that line 4, the process 2 is come. It starts, and it burst time means its execution time is 3. So 4 plus 3 equal to what? 7. Then at the point of 7, process 2 execution is done. Now come process 3 at this point. And the burst time means the execution time of process 3 is 1. That means 7 plus 1 equal to 8. So when the value is 8, so at that point the execution of process 3 is also done. Then it comes for process 4. So process 4 will need to complete the execution within 2 seconds, that is 2. That is the burst time. So 8 plus 2 equal to 10. So 10 is the completing time. And now for the last process means the process 5. In the process 5, it restarts from 10 means this line, and the total burst time means the total execution time is 5. So 10 plus 5 equal to what? 15. So that is the burst time. So 15 is the completing time. So guys, do you clear about the completing time, that how this completing time is come? If you have any confusion or any question, you can ask.
Ma'am, Basta will be given, right?
Can you repeat?
Yes, why? Tell me.
Ma'am, Basta will be given.
Yes, in the exam, I will give the process number, arrival time, and the burst time. These three things. And you have to find out the completing time, the turnaround time, and the waiting time.
Okay, ma'am.
Okay, then any more question? So all of you clear?
Yes, ma'am.
Yes, ma'am.
Then Now see this problem. In this problem, there are three processes. Look at the arrival time. Here the arrival time, the sequence is from, there is a normal sequence that is from 0, 1, 2, 3, 4. Differences between one arrival to another arrival is 1. But look at this arrival time. First process come at 0 second. After 3 seconds left, the second process is come at 3 seconds. After 2 seconds left, then the third process come at 5 seconds. Now and the bus time is already given. Now at that point, how you can calculate the completing time. So as there is some time gap between one process to another process, if the time gap is more than 1, at that point of time, the calculation process of first come first serve algorithm is become different. At that time, to counting the completing time, you need to add burst time plus arrival time. So 2 plus 0 equal to 2. Then 3 plus 1 equal to what? 4. 5 plus 6 equal to what? 11. Another thing is, for calculate the turnaround time, the formula is completing time minus arrival time. And to calculate the waiting time, the formula is turnaround time minus bus time. So, whenever you look at this column, that turnaround time minus 0 equal to 4. 7 minus 1 equal to 6. 8 minus 2 equal to 6. 10 minus 3 equal to 7. 15 minus 4 equal to what? 11. And to calculate the waiting time, the formula is turn around time burst time. Turnaround time is 4. So 4 minus 4 equal to 0. 6 3 equal to 3. 6 minus 1 equal to 5. 7 minus 2 equal to 5. 11 minus 5 equal to 6. Then you also need to show the average turnaround time is 4 plus 6 plus 6 plus 7 plus 11 divided by the number of processes. So here total number of processes is 5. And to count the average waiting time, that is 0 plus 3 plus 5 plus 5 plus 6 divided by total number of processing time. Total number of process. That means divided by 5. Now tell me, do you have any confusion in this slide?
Ma'am. Miss, can you hear me?
Yes, I can hear you. Tell me.
Miss, in the grand chart, ma'am, why did it start from 0? Ma'am, grand chart is showing the time, the completing time or something else?
Your
Miss, in
voice
your in
is
the
cutting down.
ma'am, in the algorithm you are showing in the Word file, the grand chart started from 0. The grand chart shows
You asked about this.
Miss the grand chart.
Okay, you have problem in this Gantt chart, right?
Yes, miss.
So here you see there are three process. Process 1, process 2, process 3. So first of all, first see when the process 1 is come at 0 and the burst time is 2. Okay. Now the processor is waiting. My CPU is waiting. Then when the process will come. So you see after 3 seconds, the second process is come. The arrival time is 3. So that's why you see this zigzag thing. This is actually showing that the processor is actually waiting, and at that point of time the processor is now free and is waiting for the another process, and it has nothing to do with it to work. So when it is free, at that point of time the process 2 is come. Whenever the process 2 is come, so at that point of time, we will calculate the completing time is as there is a huge gap from one process to another process. So 3 plus 1 equal to 4. So after 4 minutes, the process 2 task is also done. Now again, when the 5 will come, it will actually waiting. The processor here is waiting. You see the zigzag sign, this is the processor is waiting because processor has nothing to do now. Processor is totally free at this point of time. So that's why it is waiting for another task. So whenever at point 5 means arrival time 5, process 3 come and the burst time is 6. As there is a huge gap between 3 and 5 means 2 second gap. So it is do the calculation between arrival time and burst time for find out the completing time. So it is 5 plus 6 equal to 11. Do you clear or confusion?
Yes, ma'am, clear.
Okay. So anyone have a confusion from the first mathematical problem with the second mathematical problem? Okay. So always remember the tips, that is if the arrival time it will do, you will count the completing time as completing time plus the new burst time, that is 7. Then completing time, then the new burst time, that is from one process to another process, there is a huge difference between the arrival time. It is upper than 1, it is greater than 1. At that point of time, to calculating the counting time, you will do 0 plus 2 equal to 2, 3 plus 1 equal to 4, 5 plus 6 equal to 11, like this way. Yes, anyone have any question or do you want to say anything?
No, ma'am.
Do you have any question, guys?
No, ma'am.
Okay. Then, actually, CPU is wait for the process. Process never even wait for the CPU. CPU is always free. Here you see CPU is free. But CPU is actually waiting for the process. And the second important thing is, in the question, if I does not give any arrival time, at that point of time, by default, you will always take all of the arrival time as 0. Whenever you do all of the arrival time, at that point of time, you start your Gantt chart according to the lower number to the higher number of your process. And you will do your math like this way. You will calculate the completing time by this way. The thing I write in the Word document, you will write your math in this way, not in this way. You will calculate your mathematical formula like this way, not in this way. Whenever if I don't give the arrival time value at that point of time, you set up all the arrival time value is 0. Do you clear, guys?
Yes, miss.
Yes, ma'am.
Then now see this problem. Now see this problem. First look at this left hand side chart, not the right hand side. First look at this chart. You see there are 3 processes. Process 1, process 2 and process 3. See the arrival time. Process 1 comes when the time is 0. Process 2 and process 3 also come the same arrival time, that is 1. Same arrival time. Now what you will do? As the process 1 comes first, the arrival time is 0. You place process 1 first in the Gantt chart. Then between the process 3 and process 2, both are arrival at the same point of time. So in the Gantt chart, you will place at first process 2, because the process number is less, you will put it in the first position. So this process number is less, you will put it in the first position, then you go for process 3. After that, here the between the arrival time gap is 0 to 1, not more than 1. So that's why you will calculate the completing time as like as, so from the first process, the bus time actually our completing time. So for the second process, it will be 20 plus 2, because to complete the second process, the total bus time is 2. So 20 plus 2 equal to 22. And go for the third process. Whenever you move to the third process, at that point of time, see, 20 plus 1 equal to 23. So the completing time for process 3 is 23. So do you clear in this mathematical part, guys?
Yes, ma'am.
Yes, ma'am.
Then look at this part. So in this part, it will be written, okay, I will say it later. So in this part, it is also 3 processes. Now first process arrive at with 1 second. So it is 1. Look at the second and third process. The second and third process both are alive in when? 0. Now that means before process 1, the process 2 and process 3 is arrived. So for that reason, in the Gantt chart, I will place first process 2 and process 3. then I will go for process 1. So whenever I go for process 2 and process 3 both, process 2 and process 3 both are arrival within the same time. Both of are 1. So at that point of time, we will think that which process number is less. So 2 is less than 3. As 2 is less than 3, so we will at first put process 2 in the Gantt chart. Here I put. And the bus time for process 2 is 2, so the completing time will be 2. Now come to process 3. Whenever I move to process 3, so the bus completing time and total bus time is 1, that is 2 plus 1 equal to 3. So the completing time of process 3 is 3. Now come to the process 1. Whenever we come to the process 1, now the bus time is 20. So 20 plus 3 equal to 23. So total completing time is 23. And here you written not 3, it will be 23 in this box. So guys, do you clear in this part or confusion? Tell me.
Clear, ma'am.
Okay guys, just 1 second. Okay, so you have confusion in this part. So here see, 3 processes are there. The process 1 arrival time is 1. Process 2 and process 3's arrival time is 0. That means process 2 is and process 3 come earlier than process 1. Now what will happen? As these 2 and 3, these 2 process arrival time is smaller, that means these 2 are come earlier. So at that point of time in my Gantt chart, I will put the value of process 2 and process 3 first. Then I will put the process 1 value. So in the Gantt chart, which value which process I will take, 2 or 3? Between 2 and 3, 2 is smaller than the 3 according to the process number. We always put the value in the Gantt chart according to the process number. So process number 2 is smaller than the 3. So at first I put process 2, then process 3, then process 1. Now come to the working tasks. So arrival time of process 2 is 0. I write here 0 and the bus 2. So I write here 2. So completing time is 2. Now come to the process 3. So process 3 come in this part. And bus time of process 3 is 1. So 2 plus 1 equal to what? 3. So the value of process 3 is 3. Now at that point, process 1 is come. Now total bus time of process 1 is 20. So 20 plus 3 equal to what? 23. So the completing time of process 1 is 23. So guys, in this box you will write 23, not 3. Do you clear or confusion?
Yes, ma'am, clear.
Okay. Now see this exercise. So here you see there are 4 processes. Total 4 processes. And the first process arrival time is 0. seconds left, then the process 2 and process 3 come. Then again after 3 seconds left, the process 6 is come. Now what will be the counting time for process 1?
Ma'am, 2.
Tell me.
2.
Yes. For the first process, it is 2. Then, now tell me what will be the, now tell me in the Gantt chart which process you place first. After process
Number
1,
one.
then process 2 or process 3 you will place. Tell.
2, ma'am.
Okay, good. Now tell me what will be the completing time of process 2.
Ma'am, 7.
Yes, that's good. Now, tell what will be the completing time of process 3. 6. I told you that if the arrival time 0 to at that point of time, I will do the calculation of completing time is my burst time plus the previous completing time. That means 3 plus 7 equal to 10.
10. Yes, ma'am.
And now tell me what will be the completing time for process 4.
12.
Yes, very good. So you see, by this way, your process will be worked. Now, see the second exercise. So in this second exercise, there are also 4 processes. But look at here, the arrival time. Process 1, 2, 3, all of them arrival time is 0. So according to the less number of process, I will set in the Gantt chart as process 1, process 2, process 3, then process 4. Now, up to 3, 1, 2, 3 process, there is no arrival gap. The gap is from 0 to 1 means 0. So, for this, for the first process, the completing time is 24. For the second process, the completing time is previous completing time plus new the process burst time, that is 3 plus 24 equal to 27. Now process 3. So previous completing time plus new process burst time, that is 24, 27 plus 4 equal to 31. But see, there is a gap from process 3 to process 4. Total 3 minutes gap, there is a gap. So for this gap, after 3 minutes, it will start its work. That is, the burst time is 1 and arrival time is 3. So 3 plus 1 equal to 4. So the completing time of process 4 is 4. Do you clear, guys, or confusion?
Clear, ma'am.
Okay. Guys, always remember how to calculate the completing time in first come first serve algorithm. You have to always remember the arrival. If the arrival time gap is from 0 to 1, at that point of time, previous completing time plus new process burst time, this way. But if the gap is greater than 1, so at that point of time, you will calculate the completing time as arrival time plus burst time. Otherwise, your math formula will be, all of the values will be mismatched. Because in the exam, I will give several types of mathematical formula. You have to calculate it, and also the value for my mathematical formula will not same with this slide. That will be totally different. The working process will be same, but the value will be totally different. Clear, guys?
Yes, ma'am.
Then we will move on to the shortest job next. This is also non-primitive scheduling. Shortest job next is also called shortest job first, means the job that is short that will work fast. And the shortest job first, the advantage is it always think about that which job need a smaller time. So in the previous work, in the previous algorithm, first come first serve, you see that they does not think about the time. They always think about the arrival time, that which process come first, I will go with that process. But short job next scheduling actually work for the job, the process that is most smallest, that job will be do at first. Then it go for the big process. Here is written, it is impossible to implement in interactive system where required CPU time is not known. Interactive system means, for example, if my processor is work as like first come first serve, this way at that point of time it cannot do the short job next scheduling algorithm. Because you see in the previous class in Microsoft 3.1 and Macintosh operating system actually use the non-primitive scheduling, and if their scheduling system is only work-based as like a first come first serve, at that point of time they cannot interact the process. That means, say for example, in first come first algorithm, it focus on the work that process 1 comes 0 second, so I will establish process 1. Whether the process 1 is too much big, it takes 25, 20, 30 seconds, even 1 hour, it does not care for it. But our shortest processors should know in advance how much time process will take. So, for doing this type of algorithm, mathematical algorithm, your processor definitely have the idea that how it will do the process work. Let me write the mathematical problem for you. Then I will discuss it with you.
Ma'am, are you there?
Yes, I am there, guys. Let me first draw the mathematical formula. So in the exam, I will give you. Okay, 1 second. So in the exam, for short talk next scheduling, for that program, also I will give the process number, arrival time, and the bus time. Now, first of all, see here, all of the process arrival time is 0. Now, according to the bus time means total execution time that the process need to execute. So, first process needs 6, second process 8, third process 7, fourth process 3. So, fourth process needs the smallest time to complete. So, it will start from 0 and end with 3. So, my completing time for process 3 is 3. Now, after process 3, what is the smallest? 6, 8 and 7. The 6th is now most smallest. So, now I will put my Gantt chart process 1. So, bus time is 6. So, 6 plus 3 equal to what? 9. So, my process 1 completing time is 9. Now, between 8 and 7, which process is smallest? 7. So, I will put process 3 in here, and 7 plus 9 equal to what? 16. So, it will be 16. The completing time is 16. And at last, the process 2. Because my process 2 is the biggest process. And its bus time is 8. So, 16 plus 8 equal to 24. So, I will place 24. So, guys, do you clear up to this?
Yes, ma'am.
Okay. For your turnaround time waiting time, the formula is always same. For your turnaround time means your counting time minus your arrival time, and waiting time formula is turnaround time minus burst time. So if you find out the counting time, so it's a piece of cake for you to count the turnaround time and waiting time. Do you have any confusion about turnaround and waiting time, guys?
No, ma'am.
Okay. Now
No, ma'am.
go for another types of problem in shortest of first. So first of all, see. There are total 5 processes. In the previous math, all of the arrival time is what? 0. So that was little bit easy for us to find out which process is smallest from the burst time. Now look at this mathematical term up to burst time. Okay. For first process 1 is come and its burst time is 7. So now see at the Gantt chart. So in the Gantt chart, you see that here it is a zigzag thing that is from 0 to 1, because always arrival time is start to calculate from 0. Here I didn't put any 0. That means for 0 to 1, the process is actually waiting for some time. After that, at point 1, the first process is actually come. When the first process is come, it don't go for the another process. Okay, it at first calculate the burst time and the completing time. So the completing time for the first process is 8. 1 plus 7 equal to 8. Now inside 8, you see, it take total 8 seconds. Inside C, inside 8 seconds, already the other 4 processes come. 2, 3, 4, 5, and all of them are take within 1 by 1 second, all of the processes come. Now it start to check that which process is smaller. So among them, according to the burst time, the smallest process is number 3. So here it put process 3 and it calculate 1 plus 8 equal to what? 9. So the completing time of process 3 is 9. So I got 9. Now this process is done. First process done. Now 2, 4, 5. These 3 processes are remaining. So between 2, 4, 5, the most smallest process is 2. This burst time is 2. That means now the most smallest process is 4. So I will put the process 4 in here and the burst time is 2. So 9 plus 2 equal to what? 11. The completing time is 11. That is 9 plus 2. So process 4 is also done. Now remain process 2 and process 5. Between 2 and 5, which process is bigger? Which process is smaller? Process 2 is smaller because its burst time is just 5. So now I will put process 2 in here and 5 plus 11 equal to what? 16. So I got the 16. Now the last process, that is 5, I will keep the process 5 in here and the burst time is 8. So 8 plus 16 equal to what? 24. So the completing time of process 5 is what? 24. Guys, do you clear in this math or confusion? Tell me.
Clear, ma'am.
Okay. Guys, can you see the attendance screen?
Yes, ma'am.
Yes, ma'am.
Okay. Guys, do any one of you know Mahabubur Rahman? Any of you?
No, ma'am.
No, ma'am.
Okay. Serial 1,
Yes, ma'am.
2, serial 3,
Yes, ma'am.
4, serial 5, 6,
Yes, ma'am.
7,
Yes, ma'am.
8,
Present, miss.
9,
Yes, ma'am.
10, 11,
Yes, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Present, ma'am.
15,
Ma'am, he has internet problem.
okay, 16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Present, ma'am.
19,
Yes, ma'am.
20,
Present, ma'am.
21,
Yes, ma'am. Yes, ma'am.
22, 22, present or absent? 23,
Yes, ma'am.
24, 25, 26,
Yes, ma'am.
27, 28,
Present, ma'am.
29, 30,
Ma'am, he has internet
Present, ma'am. Okay. Okay, 31, 32,
Present, please.
33,
Present, ma'am.
34, 35,
Yes, ma'am.
36,
Ma'am, 29.
36, 36, 37,
Yes, ma'am.
38,
Ma'am, she have electricity problem.
okay, 39,
Yes, ma'am.
40,
Yes, miss.
41,
Yes, ma'am.
42,
Yes, miss.
43,
Yes, ma'am.
44.
Present, ma'am.